A small vessel moved toward the Russian-held coast at Kinburn Spit, but there were no sailors inside and no soldiers waiting to storm the beach. Instead, the boat was carrying a tracked combat robot armed with a machine gun. As it reached the shallow water, the front ramp opened. The machine rolled into the sea, climbed onto the sand, and moved toward Russian positions while its operators remained far from the battlefield. Ukraine says this was the first combat mission of its kind, an amphibious attack carried out entirely by unmanned systems. That claim has not been independently confirmed, but the operation points to a much larger change taking place across the war. Ukraine is now linking naval drones, ground robots, reconnaissance aircraft, and strike drones into one battlefield network. These machines are entering areas filled with mines, artillery, and enemy surveillance, where sending infantry could carry a deadly cost. But can robots truly replace soldiers, and how quickly can Russia respond? Stay with Military Force as we examine the rise of Ukraine's robotic army and the new race to control the battlefield without putting humans on the front line. The Kinburn operation marked a step in Ukraine's use of unmanned weapons because it linked a naval drone with an armed ground robot. On July 13, 2026, Ukraine's 123rd Territorial Defense Brigade released footage from the Kinburn Spit. The video showed an unmanned surface vessel moving toward a Russian-controlled shoreline while carrying a combat vehicle. No landing team was inside, and no soldier had to sit behind the weapon. The approach was controlled from a safer position, shifting the risk from life to equipment and setting up the hardest stage near shore. As the vessel entered shallow water, its front ramp lowered and the ground robot moved forward. It crossed the water, reached the beach, and continued onto land. The machine opened fire at a Russian position, although the brigade did not identify the target or publish a battle report. The footage shows the landing and the weapon being used, but the damage and Russian response remain unclear. That gap matters because military judgment needs more than a short video. Ukraine described the event as the first known combat mission of this kind in the world. That wording must be treated carefully. It is a claim from the Ukrainian side, not a record confirmed by an independent body. The operation was unusual. Ukraine had used naval drones against ships and ground robots for transport, mine clearing, rescue, and direct fire. What changed at Kinburn was the connection between them. The sea vehicle became a carrier, while the ground machine became the weapon delivered to the coast, creating one chain from water to land. The mission was not fully autonomous. Human operators guided the vessel, watched the camera feed, controlled the robot, and decided when to fire. The most accurate term is remotely operated unmanned systems, not independent machines making battlefield choices. Ukraine is not removing people from war. It is moving them away from the exposed point while keeping them inside the command process. The operator remains responsible, but the machine absorbs the danger that would normally face a landing party, changing how an amphibious approach can begin. This was not a full amphibious assault. A traditional landing places troops on enemy territory to seize ground and hold it against a counterattack. At Kinburn, the immediate goal appears narrower. Ukraine delivered armed firepower to a defended coast without committing infantry during the first stage. This is better understood as a robotic amphibious insertion. It can test defenses, attack a fixed point, draw enemy fire, or prepare the way for another force. The robot becomes a tool for access rather than a replacement for soldiers, creating a wider problem for Russian coastal defense. Russia must now watch more directions at the same time. Coastal units search for boats, low-flying drones, artillery fire, and small assault teams. A vessel that can carry a weapon onto the beach adds another threat. Moscow may need more cameras, patrols, electronic warfare, and direct fire weapons along areas once considered too difficult for a landing. Even if one machine causes limited damage, it can still make defense more expensive because every possible landing point may demand attention. Important details remain unknown. The brigade did not clearly identify the vessel model, the ground platform, its control range, or the final target. Some reports suggested that the robot carried a Wally 7.62 weapon station, but the original unit has not confirmed that detail. The distance traveled across the water also remains uncertain. These gaps do not erase the importance of the operation, but they limit what can be claimed with confidence. Once the vessel had solved the problem of reaching the coast, the next test began on land, where Kinburn's sand, shallow water, and marshy ground would decide whether the robot could keep moving and fighting. The robot used at Kinburn had to do more than leave the boat, because the ground was soft and difficult to cross. The spit is made of sand, shallow water, reeds, and marshland. A wheeled vehicle could sink or become trapped before reaching its target. A tracked UGV spreads its weight across a wider surface, so it can move with better control on loose ground. That gave the machine a chance to keep advancing after the naval vehicle completed the crossing, and the terrain became the first test of whether the mission could continue. Its low body also reduced how much could be seen. That made detection harder among dunes, grass, and broken ground. Still, there is no data proving that the robot could not be detected by radar. The safer conclusion is that its small size may have reduced its signature, while the true level of protection remains unknown. The machine still depended on cameras and a stable data link, which turned communications into the next challenge. The onboard camera gave the operator a view and allowed fire to be controlled from a safer location. Yet the robot did not need to destroy an entire Russian position to be useful. It could force troops to leave cover, draw defensive fire, test how quickly units reacted, or hold one direction while a drone watched from above. It could also reveal routes for later operations by showing where the ground was passable and where defenses were strongest. In this role, the UGV became both a weapon and a sensor, making the mission more valuable than one burst of gunfire. Kinburn's spit gave the operation meaning because of its location. The narrow strip lies between the Black Sea and the Dnipro estuary, close to sea routes toward Mykolaiv and Kherson. Russia has held the area since 2022 and used it as a military position on Ukraine's southern coast. From there, forces can watch waters, support coastal defense, and threaten activity around the river entrance. This made Kinburn more than an isolated beach, and any sign that Ukraine could approach it by remote systems carried military and political weight. Ukraine said in late June 2026 that its forces had pushed Russian troops from several positions and raised a flag on the spit. However, the Ukrainian Navy warned that it was too early to say the whole area had been liberated. That distinction matters. The robot mission was not proof that Ukraine had taken Kinburn, and it did not show that Russian defenses had collapsed. It was better understood as a test of access and response. The operation showed what might be possible without proving that the battle had been won. The main value of the mission was not territorial control, but risk reduction and tactical choice. A small unmanned carrier could approach a coast that might be mined, watched, or covered by fire, then place a weapon where soldiers would face danger. Russia would need to watch not only troop-carrying boats, but also vessels able to deliver robots, sensors, explosives, or other payloads. That could force Russian units to spread cameras, patrols, electronic warfare systems, and weapons across a wider area, raising the cost of defending every landing point. Even so, the limits remain clear. A UGV can approach, observe, and fire, but it cannot search trenches, question prisoners, treat wounded soldiers, or hold ground for long periods. Infantry is still needed to enter buildings, clear hidden positions, and defend captured terrain against a counterattack. Kinburn therefore did not show that robots had replaced landing troops. It showed that machines could prepare the way, reduce exposure, and create options before people were sent forward. That principle would soon appear when Ukraine paired ground robots with reconnaissance and strike drones along the front line. In an operation described in the transcript as taking place near Huliepol, Ukraine used ground robots as the direct fire element while drones controlled the space above. The 33rd Separate Assault Regiment later released footage showing at least 2 unmanned ground vehicles moving toward a Russian position. Their job was not to act alone. They were part of a wider system that included reconnaissance drones, FPV strike drones, a heavy multi-rotor aircraft, remote operators, and troops waiting behind the line. This combined structure turned several small machines into one coordinated assault. The first task belonged to the drones in the air. They watched the Russian defenses, checked the route, and looked for movement around the buildings. This overhead view gave Ukrainian operators a wider picture than the ground robots could provide. It also reduced the risk of sending men across open ground without knowing where the strongest fire might come from. Once the path appeared clear enough, the UGVs moved forward and took the most exposed role. Reports published on July 17th identified the vehicles as Droid TW-12.7 systems made by the Ukrainian company DevDroid. Each platform was fitted with an American M2 Browning heavy machine gun chambered in 12.7 millimeters. That weapon can deliver stronger and more sustained fire than a small FPV drone, especially against walls, firing points, and light cover. The robot could stop at a safer distance, aim through its camera system, and keep pressure on the target without placing a gun crew beside the weapon. The assault followed a clear sequence. The drones found the position and watched the approaches. The ground machines advanced first, then used heavy fire to suppress the buildings and force the defenders to react. When a Russian soldier reportedly left one structure and tried to move toward another, a Ukrainian drone struck from above. This showed how the two systems covered different escape routes. The UGV threatened movement at ground level, while the aircraft watched from a higher angle and attacked exposed targets. The regiment said the Russian position was completely destroyed, but that claim came from the unit involved in the fight. The public video confirms that robots advanced, fired, and worked with drones. It does not prove every casualty, the full condition of the site, or what happened after the footage ended. The exact date of the operation was also not released. The video appeared on July 14th, while later reporting added more detail on July 17th, so those publication dates should not be presented as the day of the battle. The location also needs careful wording. The transcript uses the name Geopolitical, which likely refers to Huliaipol, but the reports checked so far did not clearly identify where the mission took place. For that reason, the safest description is an operation that the transcript places near Huliaipol. This may sound like a small detail, yet accurate geography matters because battlefield claims can quickly become larger than the evidence behind them. The deeper lesson is that the UGV was effective because it did not work alone. The ground platform had endurance and a powerful weapon, but its view was limited by walls, trees, and terrain. The drones had a much wider picture, though they carried less ammunition and could not stay under fire for long. Together, they reduced the number of soldiers who had to enter the kill zone during the opening stage. That difference separates a battlefield tool from the wider claim that machines can replace people across the front, which the evidence does not support. Even so, infantry was still needed to check the position, clear hidden spaces, and hold the ground afterward. These combat videos gained attention, but the larger robotic shift was taking place in quieter missions, such as supply delivery and casualty evacuation. The biggest change is not the sight of a robot carrying a machine gun. It is the speed at which Ukraine is turning ground robots into daily battlefield tools. In January 2026, Ukrainian units reported 7,511 missions using unmanned ground vehicles. By June, that figure had reached 16,676, an increase of about 122%. Across the first half of the year, these machines completed more than 66,300 missions, showing that UGVs were moving beyond small trials and into regular military use. Most of those missions were not direct attacks. They involved carrying ammunition, food, and water to positions under threat. Other systems evacuated wounded soldiers or recovered the bodies of those killed. This distinction matters because combat videos often receive the most attention, while logistics usually decides whether a unit can keep fighting. A trench without ammunition, medical support, or fresh supplies can become impossible to hold even before the enemy launches a major assault. The mission count also reveals a change in military economics. A truck may carry cargo, but it is easier to detect, and its loss can kill a crew. A smaller UGV moves less material, yet several can operate on routes and spread the risk. This does not make them cheaper in every case, but it gives commanders another way to keep supplies moving under surveillance. That pressure has grown because the area behind the front is no longer safe. Reconnaissance drones watch roads and tree lines. FPV aircraft strike vehicles, small groups, and exposed movement. Artillery can hit routes after a target is found, while mines block the few paths left open. In some sectors, the dangerous zone extends far behind the first trench. Sending a supply team through that space may risk several trained soldiers just to deliver one load, while a lost robot can be replaced without creating another casualty. Ukraine therefore wants machines to take over as much frontline logistics as conditions allow. The Defense Ministry has spoken of moving toward fully robotic supply work in suitable areas. But this remains a policy goal rather than a result already achieved. Terrain, weather, electronic warfare, and unit readiness will decide where such a system can work. A tracked vehicle may cross mud or shell holes, yet another design may fail on the same route, which makes planning more complex than simply buying large numbers. The scale of procurement shows how serious the effort has become. By July, Ukraine's Defense Procurement Agency had contracted more than 22,000 UGVs for 2026, almost twice the total for the previous year. Most were logistics platforms, followed by engineering systems and then combat models. On April 27th, President Volodymyr Zelensky also ordered the Defense Ministry and General Staff to secure at least 50,000 ground robotic systems during 2026. That number is a supply target for the year, not proof that Ukraine already has stable annual production at that level. Mass deployment will create a second challenge: standardization. Thousands of robots need trained operators, common batteries, spare parts, secure control links, and repair teams close to the battlefield. Units must also connect them with command networks, so routes, threats, and mission results can be shared quickly. A machine that breaks down after one trip adds little value, while a platform that can be repaired and returned within hours becomes part of a working military system. This is why the success of Ukraine's robotic program will not be measured only by how many vehicles leave factories. It will depend on how often they reach the front, how many missions they complete, and how quickly damaged systems return to service. As the fleet grows, Kyiv hopes to reduce pressure on its limited manpower. But that advantage will be tested by technical failures and by Russia's own effort to expand ground robotics. Ground robots can reduce the number of soldiers exposed to fire, but they are not decisive weapons, and Ukraine does not own this technology alone. A small UGV can carry ammunition, evacuate a wounded soldier, scout a route, lay mines, or bring a weapon closer to the enemy. Its low shape is harder to notice than a truck or a group of troops, which makes it useful on roads watched by drones. That advantage begins with saving people, but it reaches beyond casualty numbers. These machines can also keep units supplied when normal movement becomes too dangerous. Many are built to be cheap enough to replace after several missions, rather than protected like heavy armored vehicles. If one is destroyed, it does not remove a trained driver, medic, or supply team from the force. A robot firing from cover may also create pressure because the enemy can hear the weapon without seeing the operator. However, no public data proves how much it changes Russian morale. Brigadier General Andriy Beletsky, commander of Ukraine's 3rd Army Corps, has argued that units using UGVs well could reduce frontline infantry needs by up to 30% by the end of 2026. That is an assessment from one Ukrainian commander, not a result confirmed across the military. It shows Kyiv's goal: use machines to reduce the number of people needed in exposed positions. Yet reducing infantry is not the same as removing it. A robot cannot fully clear a town or hold it under every condition. Soldiers are still needed to search trenches and buildings, identify civilians, capture prisoners, treat casualties, and defend ground after the enemy pulls back. UGVs can support these tasks, but they cannot handle every decision made at close range. A successful video may show the machine reaching its target while hiding systems that became stuck, lost power, or failed before arriving. That gap leads to serious technical problems. Batteries can run down, guns can jam, and tracks can become trapped in mud, shell holes, or wire. A vehicle may lose its camera feed under jamming, while an FPV drone can destroy it from above. Satellite links, backup radios, aerial relay drones, and limited self-guidance may improve reliability, but they add cost and complexity. One Ukrainian officer said robots can fail to reach their destination 4 times out of 5 in some conditions. Experts, therefore, still describe them as support tools rather than a full replacement for infantry. A Statewatch report published in spring 2026 identified 32 Russian ground robotic systems, with legal manufacturers found for 29 models. At least 20 types had been recorded in combat, and more than 20 producers were linked to the field. The list included Courier, Varan, Omich, Bogomol, and Impulse M. Several major makers were reportedly outside US and EU sanctions, which may help them obtain parts, funding, and production capacity. Courier shows the range of missions Russia is pursuing. The tracked platform can be remotely controlled and has been shown carrying supplies, while other versions can support weapons. Russian sources report a payload of up to 200 kilograms, and published estimates place its speed near 35 kilometers per hour. Its control range depends on terrain and communications, so those figures should be treated as reported specifications rather than proven battlefield performance. Russia's older Uran 9 suffered serious communication failures during trials in Syria, but that history does not prove every new system has the same weakness. Both armies face electronic warfare, broken terrain, damaged networks, and constant drone observation. Moscow has also shown that it can adapt quickly in aerial drone warfare after earlier limitations. The contest will not be decided by who announces more models, but by who can build, connect, repair, and integrate them into combat units faster under constant battlefield pressure. The Kinburn operation did not make infantry outdated, but it showed how fast the borders between land, sea, and air warfare are starting to disappear. An unmanned boat can carry a weapon to the coast. A ground robot can move into danger and provide fire. A drone above can watch the battlefield and strike anyone who tries to escape. When these systems work together, soldiers can control the fight without standing at the most exposed point. For Ukraine, the goal is not to replace every soldier with a machine. It is to protect limited manpower, keep supplies moving, and create new pressure on Russian defenses. Russia is building its own ground robots, so this advantage will not remain one-sided forever. The real contest will depend on production, communication, repair, and battlefield coordination. Kinburn may be remembered as an early sign of what war is becoming: machines moving first, people directing them from behind, and victory still decided by who can hold the ground. For more military analysis, subscribe to Military Force and turn on notifications.